Hello. Today we're doing the ninth lecture in the Land and Water Use unit. This one is 5.9 on mining. So the objectives here is to describe a natural resource that is extracted through mining and or to describe ecological and economic impacts of natural resources being removed from mining. So some of the things you need to understand is what is an ore. That is what is being grabbed by the mining processes, commercially valuable deposits of these concentrated minerals that can be harvested and used as raw materials, such as metals. Metals are elements that conduct electricity, heat, and have structural properties that can be used for buildings. And these are found within ores. You can see here there's a line of the ores within, of the metals within the ore. A reserve is how much of the ore or metal is left and how many years it will last before all of it is gone. For example, iron globally is 120 years. 40 is in the United States. Only 2 more years of aluminum left in the United States, but worldwide it's 330. For nickel, we don't have any nickel left, whereas there's 75 years left globally. Overburden is another term. It's where all that material, like the soil, vegetation, and rocks, that have to remove so that you can get to the ore deposit below. For example, all this over here is overburden. It's a pain for the miners, even though it's very pretty. Tailings and slag is the leftover waste material separated from the valuable ores, metals, that is stored in ponds and mine sites that occasionally don't stay in here, but during a heavy rain may go down into streams, groundwater, or oceans. Now, there's two different major types of mining. One is surface mining. In surface mining, we remove the overburden to access the ore underneath. There are different types would be like the open pit where you go deeper and deeper and deeper. You can see one of those over by Irwindale Speedway. Strip mining, which is basically you remove a layer and then go remove more and more and more. Mountain top is basically where a lot of that is in Appalachian, where you completely destroy the mountain. And placer would be along a river or a stream. Mountain top removal is especially damaging because it removes all the landscape, all the habitats, all the streams nearby. It removes vegetation, topsoil. You have topsoil erosion, habitat loss, huge amount of stream turbidity because there's nothing holding the soil down. All the particulate matters in the air, so it's bad enough working there, but your asthma gets worse. As more ore near the surface becomes scarce, mining has to go underground. However, it is more dangerous and more expensive. In subsurface mining, what you have to do is you have to dig down so that you can get to the process. It's more expensive due to higher insurance, healthcare costs, and actually having to get down there. Risks, there's poor ventilation. How are you going to get air down there? And there's toxic gas down in there, CO2, methane, such that the area can collapse. Some of it may fall on you. You can get lung cancer, asbestos, or other things, and or fire explosions. A vertical shaft has to be drilled down so that the miners can get down, and also so that the ore can be removed. Increasingly, subsurface is being used more and more as the surface deposits are depleted. Environmental impacts of mining, not only destroying the habitat, but there are others. For example, for the subsurface, there's acid mine drainage, or for the surface, this is where rainwater goes into the mine, it goes into it. It mixes with something called pyrite, forming sulfuric acid. Sulfuric acid dissolves metals and all kinds of nasty things. The rainwater carries the sulfuric acid into nearby streams and down into the groundwater, lowering the pH, taking toxic metals like mercury, aluminum, and putting them into the water stream. Now, aluminum and mercury are toxic, but also by changing the pH, certain species can only live at a certain pH. By lowering it, you may not be able to survive, and or they may not be able to have babies. Methane is also released, not just acid mine, but methane is released. Coal mining releases methane when the rock is removed. It goes out into the mine, and then, if it's in there, that might kill the miners. So it has to be vented out. Otherwise, there might be breathing it, and there might be explosion, which is not good. After the mine closes, it continued to go out. Well, what does methane do? It's a greenhouse gas, which leads to climate change. Another thing that happens is particulate matters. Particulate matter is released. Now, that is bad by itself, but it can lead to something called black lung disease, where it builds up so bad that people die of it. There's also topsoil erosion, habitat loss, increased stream turbidity because of the topsoil. But mines can be reclaimed. What you have to do is restore the land to the original state after you're done with the mine. That includes filling in the empty hole, restoring the original contours of the land so it looks somewhat like what it used to, returning topsoil with all the nasty things like acid, metal, and tailings removed, and replanting the native plants to restore the community back to the biome that it originally was. So, an FRQ. An abandoned mine has been found to have high sulfur levels in the tailings and overburdens left at the site. Develop one environmental impact of the high sulfur content of the overburdens and tailings, and propose a solution to remedy or reduce this impact.